So tomorrow we have a quiz. The quiz will have 10 questions. None of the questions are multiple choice. They're all, you just fill in the answers. So the quiz will cover that one day that we did back on October 7th, the lesson that we combined section 4.1 to 4.3. So remember, we did this all in one day. This was the transformations. Then the quiz will also cover 5.1 to 5.3. Now, of these 10 questions, remember, don't just focus on this review that I'm about to go over. Remember, for 5.1 to 5.3, you have a warm-up for each one of the lessons. Now, we didn't do a warm-up for 4.1 to 4.3. However, we did a homework assignment. You have the notes, and then I pulled in a bunch of questions that we're going to go through right now in review. So let's go ahead and take a look. So 10 questions. Of the 10 questions, there is one proof that you are going to write all by yourself. It's going to be a nice, short, and easy proof. You can probably do it in 4 steps or less. So let's go ahead and take a look at the review that's posted. Now, before I get into the review, this is actually just a screenshot of the notes from section 4.1 to 4.3. So I just screenshotted this. This is sort of describing the 3 different types of transformations that we talked about. The first one is the translation, and that's a slide. The second one is a reflection, and that's like a mirrored image or a flip. The last type of transformation is called a rotation, and that's like a turn. You need to memorize these rules for rotating a figure. You need to know the rule when you rotate it 90 degrees, when you rotate it 180, and when you rotate it 270. For the translation, it's a slide, and you're going to be given the rule. And I'm going to show you an example of that on the next slide. However, for the reflection, all you have to do is count how many spaces away your original figure is from that line of reflection. And I'm going to show you what I mean by that in a minute. So let's go through each one of the transformations. And again, this is just the review on the next slide that is posted on Canvas. So what we did was we broke 4.1, 4.2, and 4.3. Again, we broke up 4.1, 4.2, 4.3. We put it all into one day. So 4.1 is the translation, the slides. So you're going to just take the rule that's given to you and you're going to apply it to all of the order pairs. So for example, I'm going to do number 3 here. Let's say the figure is a triangle and they want you to translate it 3 units to the right and 1 unit down. So remember, whenever a number is being added or subtracted to X, that is going to be the shift left and right. When it's added or subtracted to the Y, that's the shift or the slide up and down. So what I'm going to do here is take my original 3 order pairs. So my X is 2, 3. My Y is -3, 2. My Z is -4, -3. I'm now going to apply the rule. I'm going to add 3 to all of my X's in my order pairs. And for my Y's, I'm going to subtract 1. Doing this calculation is going to give me the new ordered pair after the triangle has been translated 3 units to the right and 1 unit down. And again, the new figure is usually indicated with a little apostrophe or a prime mark. So I'm going to add 2 plus 3, 3 minus 1, the Y, -3 plus 3 is 0, 2 minus 1 is 1, and then my new Z is -1, -4. So be able to identify the new order pairs after you're given a rule and you apply that rule to each part of the order pairs. This would be the translation or the slide. Also be able to do a reflection. So you'll be given a graph for the reflection, and they're going to ask you to graph it, and you're going to list the order pairs. They'll give you a specific line to reflect it across. So I'm going to go ahead and draw or graph the line x equals 4. It's just going to be the vertical line through 4. And now what I'm going to do, instead of memorizing rules, I'm just going to count how many spaces away each one of the 3 points are from that red line. Notice B is 1 unit to the left. So my new B, when I reflect it across this line, will be 1 unit to the right. So this will be my new B. And then for the A, notice it's 1, 2, 3 spaces away. So I'm going to count 1, 2, 3 spaces away on this side. So my new A is over here. And then for the C, it's over here 1 unit to the right of it. So now I'll just flip it over, and my new C will be 1 space away on this side. And now I can connect my points and graph the triangle that was reflected across the line x equals 4. So again, the new order pair, if you're asked to list them, my new A was the order pair 7, 2. My new B was 5, 4. And the C was the order pair 3, 1. So be able to reflect it over a given line. And then for the rotation, this is where you need to memorize the rules on the slide from the notes. So for example, if they ask you to rotate it 270, you're going to memorize, and again, if you'd rather think of this as XY instead of AB, all you're going to do for the 270 rotation is you're going to flip the order. So the Y will go first, and then the X goes to opposite sign. For the 90-degree rotation, what we're going to do here, we're going to flip the order of the letters here. So for a 90-degree rotation, it's XY, and then we flip it and make the Y opposite sign, and then keep X the same. For the 180 rotation, it's going to be XY originally, and then you keep it in the same order, but you make the signs opposite. So just memorize these rules for 90, 180, and 270. And be able to do a rotation as well. So for the chapter 5, be able to apply the triangle sum theorem, be able to apply the exterior angle theorem. So for example, on number 1, to find the value of angle x, or the measure of angle x, we're going to use the exterior angle theorem. And what that theorem states is the measure of this exterior angle is equal to the sum, meaning adding these two angles, the sum of the two remote non-adjacent interior angles. I'm going to go ahead and just add 30 plus 80, and angle x equals 110 degrees. Now, for number 2, this has 2 parts to it. It's asking us to find the value of x and y. So to find x, I'm going to just I can do this 2 ways. Notice I've got a right triangle. So in order to find the value of x, I can either use my triangle sum theorem, or I can use the corollary to the triangle sum. And I know that both acute angles of a right triangle are complementary. So if I just did the triangle sum, what I'm going to do is add 6x plus 90 plus 5x plus 2 and set those all equal to 180. So I'm going to add these three angles, and I know that the three angles of a triangle add up to be 180. So let me add my like terms. 5x and 6x is 11x. 90 plus 2 is 92. I need to subtract 92 from both sides. I get 11x equals 88. Divide by 11, and x equals 8. Now, it didn't ask me to find x. It wants me to find the measure of the exterior angle. So what I can do here is I can do two different things. I can either plug in x equals 8 into here, find the measure of this angle, and then subtract it from 180 because I have a straight angle here and there's supplements. So that's one way to do it. So let's plug it into the 5x plus 2. So 5 times 8 is 40, plus 2 is 42. And now that's the inside angle here. And again, this is a supplement, so 180 minus 42, and that exterior angle, or angle Y, is 138. The other way you could have done it is you could have also found this angle here by plugging in 8 for x here, and this angle is 48. And then we could use the exterior angle. We can just add the exterior angle theorem, add 90 plus 48, and then that would go right to 138, which equals the exterior angle. So you have options there. Number 3, it's just more practice of the same. Then number 4, be able to identify all the corresponding parts. What's going to be key is the congruency statement. Because if you notice on number 4, the two triangles aren't sitting exactly the same way. So if it asks you to figure out which angles correspond to each other, what was nice here is they gave you the congruency marks. But if they didn't have markings, I could use my statement. Angle A is the first letter, and it matches with angle D. So I could state that angle A is congruent to angle D. We did this in the warm-up. And then notice we can also show angle B, the middle letter, is going to match with E. And then also notice that B and E have the same markings here. So angle B, congruent to angle E. And then lastly, I can say that C, the last letter, is congruent to angle F. Now, if they ask you to match sides, here the sides didn't have any markings, but what I can use is that original congruency statement. So notice the first two letters right here, AB, are going to match with the first two letters here. So if they ask you to say what side matches with AB, you're going to come and you're going to look at your statement and see where AB is. They're the first two letters. So it's going to match with the first two letters of the triangle DEF. Let's say I wanted you to figure out what matches with BC. So BC are the last two. So the last two over here would be EF. So again, be able to match the corresponding part. And then you could have also done the last one as well. That would have been AC, and that's going to match or be congruent to DF, which was the first and the last, and the first and the last here. So again, be able to find the corresponding parts. What you will use is that congruency statement. Now, the next part, this is where we can write some proofs. So again, your proofs will be nice and short, just like you did for numbers 7 and 8. Now, number 6, these are not congruent. So notice the only other piece that I can come up with that's congruent here is this reflexive side. But if you trace over the sides that have the congruency marks, this side and this side, Notice this angle that's formed by those two doesn't have a mark. So because this angle is not formed by the congruent sides, I cannot show that these triangles are congruent. So number 6 is no congruence. Number 7, though, here's my good old bow tie. Notice we've got this side here, GH, congruent to HK, and then we also have FH, congruent to JH. Notice the angle that we can show is congruent by what we learned a long time ago. I've got a pair of congruent vertical angles. So I can say, yes, these two triangles are congruent, and what I would be using is side, angle, side. So let me go ahead and write this as a proof. So again, on the quiz tomorrow, I will spell out the given for you. You will not have to pull it from a picture. So for this one, I'm going to go through here and write down all of my given. And I'm pulling that from the picture, so statements and reasons. So number 1, I can state that GH is congruent to HK and FH is congruent to HJ, and this was given to me in the picture. But again, I will have written this out for you. Same thing with what you're trying to prove. We're trying to prove that these two triangles are congruent. So my next statement will be those vertical angles, and this was just like the homework question that I did. GHF is congruent to KHJ, and the reason why I can say that they're congruent is my vertical angles congruence theorem. And now I have enough information, and my last statement was what I was trying to prove, that triangle GHF is congruent to triangle KHJ, and the reason is side, angle, side. Number 8, very similar. We can do it short and sweet, 3 steps. So for this one, statements and reasons. So again, let me state all the given. I have LM congruent to NM, which is right here. So this side is congruent to this side. And then I also have this angle here, up here at the tippy top, that is congruent to the other side as well. So that'll be still in my given. So LMP is congruent to NMP, and all that was given to me. So far I've marked a side and a side that match, and then the angle, I just need to find another side, and it's the one that they share. So I can now state that MP is congruent to MP, and that reason is reflexive. And now I have enough in my picture. I now have side, angle, side, and then over here, side, angle, side. So I can state that triangle LMP is congruent to triangle NMP, and that reason is side, angle, side. Okay, so then they have just some more practice. This was similar to what I did. Again, what you're going to use is the congruency statement. You can see that angle D and angle Q are going to match. So if angle D is 29, so is angle Q. And then E and R are going to match. So this will be 123. And then you can see F and S match. So F doesn't have a number, but we could put 2x minus 2 if we needed to. But what I'm going to do instead to figure out what angle F is, I'm going to add the two angles I have and subtract from 180. So I can go ahead and add 123 and 29 and go ahead and get 152 and then subtract that from 180 and I get 28. So then that's what I can use to set 2x plus 2 equal to. So this would be more like along the lines of what you'll have to do. You would set 2x plus 2 equal to 28. And then for the side length, notice this 5y minus 7. It's ED. It's the first two letters. So you're going to match it with QR, which is over here at 38. So the other equation you would solve is going to be 5y minus 7 equals 38. Notice each equation only has one variable, so it's nice and easy to solve. So stuff like that versus a system of equations. Now again, remember, don't just focus on this review. Go back, review your warm-ups, review your notes, review the homework, everything I've given to you to study. If you've been able to do the warm-up and the homeworks, no problem, the quiz should be nice and easy.